A star expected to be positioned where the Sun is would expand to the size of Jupiter's orbit, growing enormous and unstable, potentially exploding. These events are among the most powerful releases of radio energy in the universe, producing more energy than a billion suns combined. Are we prepared for what may happen? Betelgeuse, a massive red supergiant star and one of the closest stars to Earth, has recently undergone a dramatic dimming event that has sparked attention and divided opinions globally. This dimming has led to speculation among astronomers and the general public about its potential consequences. Some scientists believe this unusual behavior could be a precursor to a stellar explosion, a catastrophic event that occurs when a star exhausts its nuclear fuel and collapses under its own gravity, triggering a massive explosion. Such an event raises concerns not only among astronomers but also among the public, as it could potentially have implications for our planet. Betelgeuse, also known as Alpha Orionis, is a prominent star in the constellation Orion, easily visible in the night sky due to its distinct shape and brightness. It holds the title of the brightest and largest star in this constellation. Recent data gathered by NASA's Hubble Space Telescope, along with observations from other observatories, reveals that Betelgeuse experienced a significant mass loss event in 2019. This behavior is unusual for a star of its type and has piqued the interest of astronomers worldwide. While solar mass ejections are common on our Sun, the unique event seen in Betelgeuse adds an intriguing layer to our understanding of stellar life cycles and the dynamics of massive stars. The exact distance to Betelgeuse remains a topic of debate among astronomers. Some estimates suggest it is much farther away, while others propose it could be as close as 724 light-years from Earth. Determining the precise distance of red supergiant stars like Betelgeuse is a complex challenge due to their immense distances and unique characteristics. Betelgeuse stands out as one of the brightest stars visible in our night sky, outshining the Sun by several times in luminosity. However, this brilliance comes at a cost, as Betelgeuse consumes its nuclear fuel at an accelerated rate, hastening the inevitable end of its stellar life. Ultimately, the star will run out of fuel, causing a dramatic collapse under its own gravity, which could lead to a massive explosion. This explosion might result in the formation of a neutron star or even a black hole. If current astrophysical theories hold true, this raises a significant question. Does Betelgeuse pose a threat to Earth? Should a supernova occur just a few light-years away, the effects could be catastrophic. The explosion of a star can emit an immense amount of light, potentially rivaling that of an entire galaxy. This means that even if Betelgeuse is far away like Alpha Centauri, the impact of its explosion could still be vast and widespread. While we have not witnessed a local supernova since the event in 1604, humanity has observed other significant explosions, such as the one in 1987 in the Large Magellanic Cloud, located 169,000 light-years away. Although that supernova had enormous effects, it posed no immediate danger to Earth. This event highlights the scale and potential impacts of such celestial occurrences. The idea of a danger zone around a supernova is intriguing, and if an explosion were to happen nearby, the consequences for life on Earth could be severe. That being said, it is essential to understand that in the grand scale of the universe, supernovae are relatively minor events compared to gamma-ray bursts, GRBs, which are far more powerful and present a different kind of threat. GRBs can have devastating effects, capable of destroying entire biospheres and inundating planets with harmful radiation. For instance, a specific type of cosmic explosion could result in the destruction of a planet's ozone layer, leaving it exposed to the harsh radiation of space long after the event has passed. This potential risk was highlighted in a recent study, which explored new dangers associated with massive stars that end their lives in explosive fashion. When these giant stars explode in a supernova, they can release an incredible amount of energy. Cosmic explosions, known as supernovae, provide a fascinating glimpse into the workings of the universe. These explosions are the remnants of stars that have ended their lives in a catastrophic burst of energy. Even long after the initial blast, the leftover material continues to shape the birth of new stars, highlighting the dynamic nature of the cosmos. One of the key roles of supernovae is their use as standard candles by astronomers. These are events like Type Ia supernovae, which reach a predictable peak brightness, allowing researchers to measure distances across the universe. This method has been crucial in understanding the expansion of the universe and led to the discovery of dark energy, a mysterious force driving the acceleration of cosmic growth. The study of supernovae also offers valuable insights into the potential habitability of exoplanets. Scientists are investigating how the radiation produced by these grand explosions might impact planets orbiting nearby stars, possibly affecting their atmospheres and overall viability for life. This research underlines the importance of understanding the environmental factors that govern the possibility of life across the universe. Supernovae have always captivated human imagination, inspiring myths, legends, and artistic expressions. The explosion of a star is not just a scientific phenomenon but a symbol of transformation, destruction, and rebirth in many cultures. Throughout history, the appearance of bright new stars in the night sky has been interpreted as signs or messages from the cosmos. Advancements in technology have revolutionized our ability to observe and study these explosive events. Space telescopes, equipped with advanced sensors, capture detailed images and spectra of supernovae, revealing their structure and behavior. Ground-based observatories also play a crucial role, allowing astronomers to respond quickly to transient events and collect real-time data. The future of supernova research is filled with exciting possibilities. With the advent of instruments like the James Webb Space Telescope, scientists will be able to gain unprecedented insights into the life cycles of stars and the dynamics of their explosive deaths. These observations may lead to breakthroughs in our understanding of cosmic evolution and the fundamental processes that shape the universe. Supernovae not only mark the end of stars but also act as catalysts for the creation of new stars and planetary systems. The remnants of these explosions can evolve into nebulae, vast clouds of gas and dust that serve as nurseries for new star formation. These regions also harbor complex chemistry, contributing to the development of organic molecules, the building blocks of life. The shock waves produced by supernovae can trigger star formation in nearby molecular clouds, a process known as triggered star formation. This interconnectedness of cosmic phenomena illustrates how a single catastrophic event can lead to the birth of new stars and planetary systems, furthering the ongoing cycle of cosmic development. In addition to their role in star formation, supernovae contribute to the distribution of heavy elements throughout the universe. The materials ejected by these explosions enrich the interstellar medium, the raw material from which future stars and planets are formed. This cosmic recycling is essential for the creation of the elements that make up Earth and, by extension, life itself. The question of whether a star like the nearby red supergiant Betelgeuse could explode in a supernova and impact Earth raises significant concerns. Although we haven't witnessed a nearby supernova since 1604, the most recent major event, observed in 1987, occurred 169,000 light-years away. While that explosion caused no direct threat to Earth, it highlighted the immense scale and energy involved in such cosmic events. The potential effects of a nearby supernova explosion on Earth are still a topic of active research. A supernova could emit a tremendous amount of light, potentially outshining the sun and even being visible during the day. However, the most concerning threat would be the intense radiation, particularly X-rays and gamma rays, which could damage Earth's ozone layer. Without this protective shield, life on Earth would be exposed to harmful solar radiation, potentially leading to mass extinction events. In addition to the immediate threat, the long-term effects of such radiation could pose significant dangers. After a supernova explosion, high-energy particles and radiation would continue to permeate the solar system, damaging the ozone layer and exposing Earth's surface to increased levels of harmful radiation. In conclusion, while supernovae are spectacular events that have far-reaching impacts on the universe, they also raise important questions about the safety of life on Earth. Understanding these cosmic phenomena, the universe is home to some of the most star and planet formation, luminous phenomena and their potential risks to our planet. For example, is crucial for both astronomers and the general public alike. Can outshine the combined brightness of billions of stars. This raises an intriguing question: what would happen if a celestial object like scarab juice were to be caught in such an explosion? In the event of a vast blast, scarab juice could become the second brightest object in the sky after the sun, despite the immense distance separating it from us. Its brightness, which is already more intense than the full moon, would make it visible even during daylight hours. The sheer force of the explosion would create such an awe-inspiring spectacle that shadows would be cast in total darkness, showing the raw power of galactic events. While the visible light emitted by such a cosmic explosion is breathtaking, it only represents a small fraction of the total energy released. More concerning than the visible light is the high-energy radiation, specifically X-rays and gamma rays, that accompany these blasts. This radiation poses serious risks, including the potential destruction of Earth's ozone layer, which protects us from harmful solar radiation. Without this protective layer, life on Earth could face devastating exposure to harmful ultraviolet rays, potentially leading to mass extinction events. In the immediate aftermath of a cosmic explosion, the intense radiation would pose obvious threats. However, the long-term effects are equally dangerous. Subatomic particles, moving at nearly the speed of light, would permeate the surrounding solar system, further damaging the ozone layer and saturating Earth with dangerous radiation. This radiation can persist for years, even decades, as it continues to affect our planet. Evidence suggests that Earth may have experienced similar events in the past. Elevated levels of iron-60, a radioactive isotope produced in supernovae, have been detected in deep-sea sediments and lunar regolith. This indicates that Earth could have been impacted by stellar explosion debris in relatively recent geological history, possibly within the last few million years. Astronomers have previously asserted that there are no nearby supernova candidates posing an immediate threat to Earth based on our understanding of gamma rays and cosmic radiation. However, new research has uncovered additional risks associated with certain types of supernovae. Some supernovae can produce high-energy X-ray radiation that can travel vast distances through space, threatening planets like Earth. In particular, the most luminous X-ray producing supernovae can strip a planet's ozone layer by up to 50%, creating conditions that could trigger an extinction event within a range of 150 light-years. Fortunately, no such X-ray producing supernovae have been detected close to Earth. Nonetheless, this research has provided new insights into the habitable zone of galaxies, the region where conditions might be suitable for life. These findings suggest that this habitable zone might be more limited than previously thought, due to the presence of high-energy radiation from stellar explosions. The boundaries of this habitable zone are influenced by several factors, including the distance from a galaxy's center, where stars form and die at a faster rate, increasing the risk of nearby supernovae. New studies show that the inner edge of the habitable zone is likely farther from the galactic center than once believed, reshaping our understanding of where life could potentially exist in the universe. So, what would the visual impact of a scarab-juice supernova look like from Earth? While Earth's biosphere would likely remain unaffected, the sight itself would be unforgettable. Experts predict that scarab-juice would continue to shine brightly for over 90 days following the explosion, reaching a brightness almost equivalent to half that of the moon, although it would be significantly fainter than a full moon. It would appear as a bright point in the sky, visible even during daylight, and casting shadows at night. This cosmic event would undoubtedly captivate observers worldwide. Over time, as scarab-juice's glow gradually fades, scientists would continue to study the remains of the explosion, revealing valuable insights into the life cycles of massive stars and the processes that lead to their explosive deaths. Understanding these cosmic phenomena is crucial for comprehending the formation and evolution of our universe. During a supernova, not only is light emitted, but a wide range of heavy elements such as gold, silver, and uranium are also forged in the extreme heat and pressure of the explosion. This process, known as nucleosynthesis, enriches the interstellar medium with the building blocks necessary for future star and planet formation. Interestingly, the remnants of a supernova, known as a supernova remnant, can become a stellar nursery, where new stars are born from the dust and gas expelled during the explosion. This ongoing cycle highlights the interconnectedness of galactic events, demonstrating how the death of one star can lead to the birth of others. Through these processes, researchers continue to deepen their understanding of the universe's evolution.